As more multimodal large language models are becoming available for public to use, the visual question and answering is becoming a trend. Today, let's find out which model is best at image analysis. For the model selection, we will pick what's the best out there. Obviously, we will have our ChatGPT with 4.0 Multimodal. We will have the Gemini 1.5. Then we'll have the Anthropic's Claude 3. Last, Microsoft Copilot, which is essentially the same as GPT model, but we'll try that anyway. I also want to find out and compare them with a couple of open source models. So on the Hugging Face, you select models and then you go to the visual question and answering. I have picked a couple of most trending or most downloaded models. One of them is called OpenBMP Lab. It is a research group from Shanghai AI Lab focused on vision-centric AI research. And then I picked another popular model called OpenBMP, and it's a GPT-4V level multimodal large language model on your phone, but we can use it on the computer to show you guys as well. And lastly, I picked one of the OG, the Salesforce Blip model, which doesn't have a quick demo here, so we have to build into the code, but that's okay. So these are the 3 open source models we're going to compare with our other 4 models. I also have a bonus model for you. As I was wrapping up the video, Claude 3.5 Sonnet has just released, and they claim in almost every category it beats the GPT-4o. I had to include this model in our battle of the best large language model for image analysis. So it's in the end of the video, and I included all 6 rounds of comparison. Now this whole video is very long. It includes very detailed review and analysis, and I tried minimal sped up because I want to show you the real performance of the model. So feel free to just skip to the parts that interest you. Okay, enough said, let's get started. To benchmark them, we're just gonna provide images and ask a few questions to these models. So I have prepared 6 images. It's a good mix of different formats, including PDF. We're going to show them a street parking sign. We're going to show them a food menu. Then there is a picture asking what this image is about. Here comes a more complicated one. We're going to show them a Japanese railway map and asking for directions. Then we want to test their foreign language detection capability, so there will be a picture with a Chinese in it. And lastly, which is the hardest so far, and I found no models can conquer or get it right, is the chessboard reading. Okay, so let's get started. Round 1. This is a parking sign, so let's start with ChatGPT. Explain this sign to me. Enter. Now, ChatGPT 4.0 has been opened up for free users. I'm the free user. Every day I have a bit of credit. There's some limit that you can have it on GPT-4, as you can see here, and this limit get reset every day. So this sign is a parking regulation sign typically found in urban areas. Here's what it means: no parking left arrow and 2p right arrow. The 2p indicates that there is a 2-hour parking limit to the right. And then there is a time explanation. Ask one more follow-up questions. Do I need to pay when I can park? Usually if it's free, which is like this sign, it's all clear. And if it's paid, there is a meter written on the sign. The sign does not indicate the payment is required for parking. Typically, signs that require payment will have additional information such as pay at the meter. Right, so I think GPT-4 did well on the first one. Here comes the Google Gemini and the exact same images and the question. Now, Google has released Gemini 1.5, which is now also free for most users. This Gemini I'm using right now, I'm not sure whether it's 1.5 Flash or 1.5 Pro. Feels like, it doesn't say clearly, but feels like this is the Flash or the cut down version, and if you go to the advanced, you will get, it's a paid version for the 1.5 Pro. Right, the image you sent is a regular traffic sign that combines 3 different restrictions. No parking, time restriction, the below symbol, and specify the hour during which parking is not allowed. In this case, parking is allowed. No parking allowed from Oh, this is completely wrong. In this case, no parking is allowed from 8 a.m. to 6 p.m. It should be the opposite. Parking is allowed between this time from 8 a.m. to 6 p.m. The restriction, the text below indicate the days of the week. In this case, no parking is enforced. In this case, no parking is enforced from Monday to Friday. Well, it looks like the Gemini is not able to understand the whole context. It's explaining these little signs individually and got a couple of things wrong. Clearly, the parking restriction is enforced from Monday to Friday. It says no parking is enforced. And enforcement is obviously maximum you can park for 2 hours. And you are allowed to park from 8 to 6. But Gemini said no parking is allowed. Let's ask a follow-up question. Can I park on the right side of the pole from 1 p.m. to 3 p.m. on Wednesday? And the answer should be yes, right? Let's see. Based on the information you provided, sign yes, you can park on the right side of the pole from. Here's one. So it got this right. However, to absolute concern, it's best double check with surrounding. The restriction implies, okay, maybe it understands it. It's just the way explain it. It's very long and complicated. Time restriction. The text below for the symbol specified hours during which parking is not allowed. In this case, no parking is allowed from 8 a.m. to 6 p.m. That's clearly wrong. So I'll say no point for Gemini on this. Next up is Anthropic's Claude. I'm thinking it's probably Claude 3, but it doesn't say in these 3 versions. Anyway, it's a multimodal, so it must be Claude 3. And same question, explain this sign to me. And let's see what Claude's response is. The sign indicates parking regulation restriction. Yep. The green zone of the sign shows 2p, which stands for a 2-hour parking limit. It also specifies that a 2-hour parking limit applies from 8 a.m. to 6 p.m. Monday to Friday. In summary, the sign communicates. Very good. It didn't talk about the non-parking or non-standing zone. Let's ask a follow-up question. Can I park on the right side of the pole from 1 p.m. to 4 p.m. So that's 3 hours. The answer should be no. Let's see whether we can trick the model. Based on the information, you would be able to park on the right side of the pole from 1 p.m. to 4 p.m. on Wednesday. It says you can, which is wrong. Since your parking proposed is 1 p.m. on Wednesday falls within. Well, it clearly doesn't know how to do the math. Since your proposed parking zone time from 1 p.m. to 4 p.m. falls within the 2-hour window and it's weekday, you will be allowed. That is completely wrong. Let's ask, how many hours is that from 1 p.m. to 4 p.m.? Well, this might not be 100%. Actually, it got it right. And why do you say I can park? It exceeded the limit, 2p limit. I can not give you a point for that. My previous response is incorrect. Sorry. Next up is Microsoft Copilot. We upload the same image and asking the same question. Explain this sign to me. Now, I will expect it will provide a very identical answers from the ChatGPT. After all, they underline the same models. So the sign in the image is a parking sign. Red circle means no parking. Actually means no standing. Parking and standing is different. So maybe, not sure whether the model knows that. Indicate 2-hour parking and there are times within 2 hours. Okay, very similar. Now let's ask this tricky question. Can I park on the right side of the pole from 1 p.m. to 4 p.m. on Wednesday? I did ask this question on ChatGPT. I think I'm going to ask that. So this is wrong already. It's at 3 hours, exceeded our limit. The model says yes, according to the sign, you can park on the right side of the pole. This is within the specific time range when 2-hour parking limit. Oh, that is wrong. Very wrong. How many hours if I park from 1 p.m. to 4 p.m.? And the answer is 3. And I'm sure you can get it right. See, the model gets it right, but can't combine this knowledge with the question I ask. However, please note that sign indicates 2-hour parking limit during a specific time. So even though the time period is within, it keeps saying even though the time period from 1 p.m. to 4 p.m. is within the allowed parking time, but it is not. 3 is bigger than 2. But it also said you would exceeding the 2-hour limit by 1 hour. Should I give it the point or not? In terms of image analysis, you pretty much got what the sign is. But when I ask a simple question, it's very basic math. Can I park if it's 3 hours, which it knows it's 3 hours? It says, yes, according to Sonnet, you can park. That is a no. So just to be fair, I'm coming back to ChatGPT and ask the same tricky question is, can I park on the right side of the pole from 1 to 4, which is 3 hours? We are expecting answer of a no. And it also says, yes, you can park on the right side. The 2P indicates a 2. It clearly knows 2P is 2 hour. Restriction is that. And it still says you are within the enforced hours, therefore you can park. Very confident. However, make sure you don't exceed the 2 hour limit. Well, do we give it a point or not to give it a point? It clearly knows 2P and 3P, but then my question is, can I park? And it says yes. Well, here's my thought. As an image analysis model, looks like most of them can understand what's in the image. But when you ask a follow-up question which involves a very basic math, they tend to get it wrong. Now this video is about image analysis, I get that, but this follow-up question is very natural and very basic, and you expect the model will get it right. And given these multimodal LLMs are the most powerful model, I certainly expect they can get it right. So let's ask this one last question. Let's give it a last chance. If I park from 1 p.m. to 4 p.m. on Wednesday on the right side of the pole without moving my car, would that be okay? Now, clearly that's not okay because that would trigger a 3 hours parking and you might get a fine. So hopefully I made my question very clear. So ChatGPT says it's a no, right? So I think we'll give it a pass. It's clear, I understand that. Let's try the other model. We'll also give a chance to Copilot because it said just make sure not to exceed the 2 hour limit, even though the answer is yes. Maybe yes means for large language model, yes means you can park there, but you need to obey the parking restriction. That's what it says here, right? So let's give Copilot one last chance and ask the same question. We'll make our question extremely clear, and the answer should be a no. According to the sign, the parking limit 2 hours between them. If you park from them, that would be a total of 3 hours. Let's give it a pass to Copilot as well. Looks like it got this right. With the Gemini, I would say it failed on the first image because the very first questions, it says the text symbol below specified hours during which parking is not allowed. Well, this hours specified here from 8 to 6 p.m. is opposite, is the hour that is allowed. In this case, no parking is allowed from 8 a.m. to 6 p.m., which is completely wrong. So I will not give the point to Gemini anyway, but I want to ask this question just out of curiosity. Let's say, make it clear. Based on information, it seems like you will be okay to park from 1 p.m. to on the right side. Here's why. So I clearly say without moving my car, and Gemini still tells me, yes, you can. However, since your parking extends past 3 p.m., here are a couple of things to consider. Double park, consider, right. It got this right, so it's just the way, the style it responds to you, but sorry Gemini, because your first explanation is wrong, I will not give you the point for that. With Gemini, with the Claude, I will not give the point to Claude either because it was confident telling me since your proposed parking time from 1 p.m. to 4 p.m. falls within the 2 hour limit window. I don't care what it means. It sounds confusing to human. But I'm gonna ask this question just to be fair anyway, just to be curious, without moving my car, so that will be not okay. No parking from on the right side without moving your car would not be okay according to the restrictions. So I understand that, but I'm sorry, I'm not giving the point because of the previous mistake. Next comes with our open source models. The first one is this OpenGV Labs model. Now they have quite a few models. I was gonna use this InternImage, a large-scale vision foundation model with deformable convolutions. But it says here, we currently receive a bunch of issues. Our team will check and resolve them one by one. So I decided to use the first model, which is the VL, a pioneer open source alternative GPT-4v. Sounds good, right? It has a lot of downloads on GitHub. And the only thing is, it's a model that you can use on the phone, but we're gonna demonstrate it on our computer anyway. So this is the latest model. you can click on this chat demo, which is what I did. Here we're gonna upload the image and then try the chat again. Here comes the first question. Explain this sign to me. And let's see. This is a parking sign which operates from 8 to 6, Monday through Friday. Red circle with a line through is a universal no symbol, meaning no payment is needed for parking. Well, that is very wrong. No payment. If you got that mixed up, you're gonna get fined anyway. There's no standing. Point to the green arrow pointing left and right, suggesting parking is allowed in both directions from the sign's location. Well, that's completely wrong. First arrow, one is red, one is green. It says green arrows pointing left and right. And also parking is allowed. On the left, parking is completely not allowed. So this is definitely a no. I won't even ask the other questions. The next model is this GPT-4 V-level multimodal large language model on your phone by OpenBMP. You can click on this demo just to try it out. Looks like it's quite active. Mini CPM Llama 3, so it looks like it's built on the Llama 3. It's the latest model in the Mini CPM V series. The model is built on the SIG-Lib 400M and Llama 3 AB Instruct model with a total of 8 billion parameter. It exhibits a significant performance improvement over their previous model. Okay, so not comparing with other things, just comparing with their own models. Well, let's just try it out. We have clicked on demo. That should load another G-Radio interface. I just did a Google search between the beam search and sampling. If you are looking for more precise and deterministic results, you might want to use the beam search. So let's just change that and leave everything default. I don't really understand what they are. Asking the same questions, explain this sign to me, and let's go enter and see what kind of result we can get back. The number of beams, obviously, the more you will get more thorough search results, but we'll leave it at default at 3. So our first open source model has failed on the very first question. Let's see what happened on this second one. It's slow. The sign is a parking regulation sign. Parking is prohibited between 8 to 6, Monday to Friday. S inside a red circle is the internationally recognized symbol as no smoking. But no smoking next to parking sign? Very reasonable. But in this context, it seems to be used as a placeholder or a design element rather than conveying a specific message about smoking. Very smart, this fine-tuned Llama 3. The arrow pointing in the opposite direction suggests that no parking rule applied in both directions on street. The arrows pointing in opposite directions suggest that no parking rules applies in both directions on the street where sign is posted. Alright, again, very confusing, not helpful. We're gonna ask, I'm gonna give a point on this one, but we're gonna ask these tricky questions anyway. And I'm gonna pause this because it's very slow. So the response came back as a no, but for the wrong reason. It says the sign indicates that parking on the right side of the pole is prohibited from 8 to 6 p.m., which is correct. Since 1 p.m. to 4 p.m. falls within this time frame on Wednesday, that's why during these hours is a violation. Now the result is correct, but for the wrong reason. It's not because it's prohibited. It's because it's over 2 hours. So no point to this model, I'm sorry. The last model we want to compare is this OG model, the Salesforce Blip, which has been on Hugging Face for quite a long time and has most downloads. That's because it's been there for quite a long time. So I feel like I want to compare this as well to add it to the mix. Now, unfortunately, there is no demo you can try directly on Hugging Face, but they provide a code. So let's use the code. What we're gonna do is we're gonna run this model on GPU maybe in full precision. So we're just gonna copy the code and paste to our Google Colab and making a bit of change. First, you're gonna go to your runtime and pick a GPU because we're using CUDA. And also, we're not gonna use the image URL like in the sample code. We're just gonna upload a file to this folder on the Colab. So it will be directly with this image file. So it looks like I have a bit of problem with the runtime. Let's try. Okay, let's go. We upload images, change the image path to the same file name, comment out your image URL, the one from the sample code, and just go run all. It's gonna take some time to download the libraries and get the model ready. So we have to pause this. Our Python notebook has finished loading. Let's ask the question, explain this to me. We already uploaded image on the left on that. And it says, no parking. Doesn't talk much, do you, Salesforce? Let's ask the other questions. So that's not a good explanation at all. But it's what a fresh breeze compared to all these new models. Like Gemini and ChatGPT that talk so much, that talk too much. Can I park on the right side of the pole? Okay, question. Now, first of all, there's no parking. The first question and answer is not correct because on the left is no parking. On the right, you can. Now, second question, can I park? No. Okay, that's right. Let's change that to 3 p.m., which is a yes. And still no, okay? Although you don't talk much, Salesforce Blip, you also got it wrong, so no point for you, I'm sorry. Okay, let's do it. This is a picture of a menu on the board on the in restaurant. There's some breakfast, sandwiches, salad soup, and hot drinks. And there's also a Wi-Fi password here. So we're gonna ask them 2 questions. Number 1, I wanna know, is there anything has eggs on the menu? It looks like the fact that there's nothing on the menu has eggs. And number 2, we're gonna ask password for the free Wi-Fi. This is handwritten, so let's see whether our model can read it correctly and then answer our questions. So first up, ChatGPT, is there anything has eggs on the menu? And let's see. That doesn't appear to be any item on the menu that's supposed to mention eggs. The breakfast, sandwich, hot drinks do not contain any dishes or eggs. That's good. Okay, on 4.0. Question, what is the Wi-Fi password? And let's see whether you can read it. So the Wi-Fi password you can see is Brixton_Garrisons. Oh no, this is correct. So the Wi-Fi name is Brixton Pound and the password is Garrison1. That's excellent. Okay, point to our ChatGPT 4.0. Second up, Gemini. Is there anything has eggs on the menu? Let's see what the response is gonna be for Gemini. I cannot see any item on the menu that contains eggs. The menu includes breakfast items. Okay, on the list of menu, pancake. I don't know why it interprets some of the English word into the Japanese. Must be because of the handwritten. So doremo means all in each. So shall we give the point to Gemini or let it pass? Let's ask the second follow-up questions. If it passes this, let's give a point. Wow, I don't have access to specific hotel information including password. However, this is completely irrelevant. Let's ask clearly in written that image I just provided. Well, looks like we cannot give this 1 point. Okay, it's not getting the, like there's no context. There's no conversation history throughout this chat. I just upload image and on the second round of the chat, it already says, no, I don't know what you're talking about. What hotel? Okay, let's upload the image and ask the question again. What is the Wi-Fi password in the image? In one turn, whether it makes it. But how can it not having the conversation history? Wow, I can't access the image you sent directly. That is interesting. Here's why. Maybe if the image shows the Wi-Fi network, you can search. Maybe it's because of the passwords. It has some kind of safety thing built in. But let's ask one more question. What is this restaurant Instagram handle? It's on the top, right? Let's see whether you can see it. We have the Facebook, Twitter, and Instagram. Unfortunately, I can't. Oh, this is bad. What's going on here? Let's upload image again. Well, yes, when we asked the parking sign question, we were able to ask follow-up questions, right? We don't have to upload this image again and again. This is not so good. How about we ask this question to ChatGPT? Based on the image you provide, is okay, the restaurant name is Brixton Pound and the Instagram is likely to be okay. Sorry, Gemini, you won't get this point. Just to be fair, I want to ask this same question to ChatGPT. So what is the restaurant Instagram handle? We'll ask. And it's all written on the top, right? There's Instagram, Facebook, Twitter, and also the website. The restaurant Instagram handle. Super, spot on. concise. It's just brilliant, ChatGPT. Next up, Claude. Let's ask the question, is there anything has eggs on the menu? Based on the menu, there's no mention of any item containing eggs. The breakfast section lists items like breakfast tea, spinach, tomato sandwich, blah, blah, granola. That's very good. Second question, what is the Wi-Fi password? See whether it can extract the Wi-Fi password. The image does not provide the Wi-Fi password explicitly. However, it shows on the icon says free Wi-Fi, which is correct, along with other social media icons, suggesting the Wi-Fi password SSID is likely to be Brixton Pound, which is correct, but the actual password is not displayed on the menu. Well, let's remind Claude that the password is written right under the SSID on the board. Let's see whether Claude can pick it up. So this is because, it's not because you can't read the writings on the image, it just doesn't have the reasoning to understand that Garrison 1 right under the SSID is most likely the password. Like, as human, we understand, right? So now he says, you're correct, my apology. Wi-Fi password is indeed written below that. And it says gardeners, okay. Also cannot read it correctly. It's Garrison's 1, not gardeners. So I'm sorry, Claude, no more point for you. The last closed source model, Copilot. Let's ask the same question. I'll expect it will have a very similar response to our ChatGPT. Is there anything has eggs on the menu? Yes, there are items on the menu that include eggs. Which one include eggs? There are 2 items listed that could include eggs. No, could, it didn't say that include. Was very confident that includes egg. First item is described as having bacon, egg, cheese, and spinach. Well, where is the first item? The second item includes sausage, egg, cheese. These options should satisfy. Wow, that is completely wrong. I'm very surprised. Let's zoom in on this image and have a closer look. First item, breakfast. Spanish toast with garlic tomato. Second item, either the HLT on the side or on the bottom, avocado. The sourdough toast is hallucinating, or is not, either just reading the image is completely wrong. Well, let's ask, what is the name of these 2 items? That's very interesting. One explanation could be it's not using GPT-4o, maybe it's on GPT-4 vision. I'm sorry for the confusion. Now, this is after I asked the question again. But the image description doesn't provide a specific name for 2 items. They are listed under, so clearly tells you listed under the breakfast sandwiches. This is actually 2 different categories. Right, breakfast 1 column and sandwich another column, and he thinks it's the same. This is one category called breakfast sandwiches. Second item, okay, no point for you. But let's ask the second question anyway. What is the Wi-Fi password? And see whether it can get the SSID and the password out. I'm sorry about AI. Ooh, this is similar to our Claude response. Gemini. What is the password in that image? Are they all losing the context of conversations? Or maybe it was programmed not to answer questions like the password. Image description provided does not include information about the Wi-Fi password. Alright, for the Wi-Fi password, I recommend you asking staff at the location. I cannot tell whether this is some guardrails being put in to restrict answering or just not able to read the image properly. But based on the first wrong answers when asked about the eggs on the menu, looks like it can't read the image properly. Next up, InternVL. We ask the same question, is there anything has eggs on the menu? This is our first open source model. And the answer is, based on the visible menu item, there is no clear indication that any item contains eggs. Okay, good. Second question, what is the Wi-Fi password? Would you be able to read the Wi-Fi password out? Wi-Fi password is Brixton Pound. Well, that is SSID, not the password. So I'm sure this model can read the image, but the reasoning capability is a bit short because it wouldn't be able to tell that the first word usually is SSID and after slash will be the password. So let's give a point to this. Next open source model, the fine-tuned Llama 3 by the OpenBMP lab. So ask the same question, is there anything have eggs on the menu? And we kept all the settings by default. A little bit slower than the other model. I think that's just because of the Hugging Face demo. Based on the visible portion, there's no clear indication of any dishes containing egg. That's good. Second question, what is the Wi-Fi password? Waiting for GPU to become available. Success, okay. It is slow because of Hugging Face. What is the Wi-Fi password? And the Wi-Fi password is Brixton Pound. So same as the other in open source model InternVL, it picked up the SSID, but not the password. I'll give it a pass. The last model from Salesforce, which uses the Blip architecture. As you can see, I uploaded the same image to the collab, and let's run this. Is there anything has eggs on the menu? What would Salesforce say? No. Very good. As the usual Salesforce style, very little word. Second question, what is the Wi-Fi password? Wi-Fi. That is pretty bad. What is the restaurant Instagram? I don't feel like I give this model a point. Best sausages. Oh, completely wrong. Okay, now we know. Round 3 is this photo of a hotel called Nikko Tokyo near Tokyo Bay. So let's ask the model, what does it know about this? So we'll give it a hint, it's a hotel. So what hotel is this? ChatGPT. So we're just testing how it recognizes the real world objects. The hotel in the image is Grand Nikko Tokyo, located in the area of Tokyo, Japan. That's great. Here comes the Gemini. We asked, what hotel is this in the same image? Similar, this is a round 3. It should be a cruisy round. It's the most easy round. Okay, Tokyo Bay. Okay, just says easy. Gemini got it wrong. The image you sent me shows area view of hotel. Okay, this is a completely different hotel. Now, I don't know whether maybe it used to be a Hilton and now become Nikko. Let's do a quick Google search on this. It has actually give you the address as well. So let's do a quick Google search on this to prove it correct or wrong. So let's say Hilton Tokyo Bay. That looks like a different hotel. And let's get rid of this address because this is in different area. Minatoku. That was different from our Nikko hotel before. Go to the images. It's 2 different buildings. See, this is all rounded lawn, and this is is very different. And they are in the different area as well. Hilton Tokyo Bay. Okay, Gemini. Next up is our Claude model. Just realized we're actually using Claude Sonnet, so not the largest model like Opus. So it could be a bit of comparison if we try to compare with GPT-4o. You need advanced to do the Opus. So the image shows area of Tokyo Bay and a rainbow. In the foreground, a large hotel, but it didn't tell me what hotel that is. Okay, that is a fail. Our last closed source model, the Copilot. What hotel is this? And let's see whether it can read that. Right. Hotel in the image appears to be Grand Nikko Tokyo. Is correct. So Copilot got it right. Next is our open source model, InternVL. What hotel is this? Ask the question. The hotel is Yokohama Bay Sheraton Hotel. So this is annoyed. It's completely wrong because this is in Tokyo, not Yokohama, which is another city in Japan. Here comes the fine-tuned Llama 3 model. What hotel is this? The hotel in the image is Grand Prince Hotel in Akasaka. That's also in Tokyo, probably near Tokyo Bay as well, but it's a different hotel. Here is the last model, the Salesforce Blip. I don't feel like it can get it right. Even the other 2 open source model got it wrong. Hyatt, as usual, 1 word. Round 4. I think this is gonna be a tough round. So what we have here is a Tokyo subway map. And you might be overwhelmed if you first time seeing this or you never used Tokyo subway system. It's actually very easy to use. Every color represents a train line. Now we're just gonna pick up 2 random stations, and we want to ask the model how can we get from point A to point B, and it needs to tell us which line and which stops. So let's say we're gonna pick a station here, E17, there's Kachidoki on this magenta color line, and we want to follow the line keep going until it comes to this Lobongi on E23 and do a transfer to this stop at Hilo. There could be multiple ways that achieve this. For example, if you are at our starting point E17, you can go up maybe to this line and change to this Y21, and then it's not optimal. Okay, I think the most optimal way from E17 to HO3 is follow this magenta color and do a transfer at Lobongi, the E23 right here. So if we have a look at Tokyo Metro website, and we can see we did a search here from starting point we want to go to the end point. Recommended route is what we just described. So if you click open that, you can see that to get from where we started, we will start from the Kachidoki station, which is E17. After 6th station, it asks you to do a swap transfer at Lobongi, which is from here. Follow my mouse, you'll get a transfer from Lobongi, and one more last station. Change from this magenta color line to this gray line, and then you end up in this Hilo station. Okay, I think this is probably simply scenario when you're taking a subway in Tokyo, but I think will be challenging for our models. So let's see how it goes. So remember, we are asking how can we get from point A, E17 Kachidoki station to point B, Hilo station at HO3. Okay, so let's ask the model. First we'll upload the photo. So it's a PDF file. We'll upload the PDF. I've also got an image file. No text could be extracted from this file. So it looks like this free version of ChatGPT does not allow me to upload the PDF. Just simply says can't read it. I've got an image version as well, which I prepared. So let's first ask, what do you think that is? And we'll ask our second question about how do we get from point A to point B. Okay, so image is a map of Tokyo subway route, very detailed. Give you the lines, the stations, connections, excellent. And just to confirm, we are on the GPT-4o. So let's ask the second question, how do I get from stop E17 to HO3? So remember, we are looking for a transit. So if you look at Tokyo Metro website on the right, to get to Tokyo to Hilo station, we need to change two lines, this magenta color to this gray color. So what it says, looks like it's got it right. To travel from E17 to HO3, you need to make a couple of transfers, starting at Toyo line, which is correct. Toyo line, transfer to Lobongi at T23, and then transfer to the Hibiya line in the gray. And this route involves one transfer efficiently, connects you to your destination. Wow, so very easy, got it right. So let's ask the same question to Gemini. As you can see, you can't do PDF either. So here just tells you can only do images. So we upload the image, asking the same question, what this is, and we'll ask the follow-up questions. So the image you sent is a map of Tokyo subway system. That's correct. Here are some key features of the map. Great. Now let's ask how we're gonna get from A to B. We're looking for the transfer between two lines, this magenta line and this gray line. Unfortunately, there isn't direct subway, that's fine. However, you can still complete journey by transfer. So taking the Toyo line, which is the Y line, to Tsukuda station, and then you get to this Hibiya, the gray line. Take the Hibiya line from, okay, so you can get there. This is alternative line, there's not recommended route, but let's see whether it actually can get there. So after observing this map, Gemini's answer is actually wrong. It says take this Y line from Kachidoki station E17 to Y20. So it's talking about this line. Let's zoom it. This gold line, Yarakuko line. Okay, so this line from E17 to Y20. This is Y20. This is E17, and this is the gold line. You can't get there. You have to take this Oido line, this magenta color, to this station and then transfer that. So the step one is already completely wrong. You are gonna take this line from E17 because E17 doesn't have that line. It's one stop away. Okay, so no point for Gemini. Next one is Cloud 3 Sonnet. We asked the same question. Image is subway system of Tokyo subway, right? So we got that right. And follow up is, how do I get from stop E17 to H03? Let's see where they got it right. Start at E17 on Toy Auto line, the light green line. Okay, the car is got it wrong, but it's the correct line. We are starting on this Oedo line, this magenta color. So it's actually magenta. So starting at this stop, take this line towards Higali car and transfer at E20. E20. Okay. To the line. And then what do you do? From this diamond station, take the Asakusa line towards H07. So from here, we're gonna take it from H07. Where is H07? Oops. So from this diamond station, which is here, take the Asakusa line. Which one is Asakusa line? This orange one is Asakusa line. So at this station, take this line to where? This is completely wrong. And it says get off Lobongi at H07. Well, if you take this Asakusa line, you cannot get off Lobongi because Lobongi station is right on here and it's not H07. It says H07 here. So, well, I thought this method it could be flawed because even though I'm sharing the map, because the Tokyo subway station, it's in the training data. So I was thinking before I started this could be a flaw test because the model would know it will be in their training set. Looks like that's not the case because so far none of them got it right apart from the ChatGPT 4.0. Let's ask the Copilot the same question. We're gonna skip the first one. Just go straight to the second question. How do you get from stop E17 to H03? And I'm hoping you can get it right because it should be very similar to the ChatGPT 4. So what it says. From E17 to H03, we're gonna start at E17 on the Oedo line, which is the magenta one, that's correct. Travel westbound, transfer at E24 to the Hazamon line, to the purple color. Looks like Copilot couldn't get it right either. So first it started with that E17 and travel westbound and get off at E24, which is okay. Alright, you're taking different routes. So we follow this magenta line and get up at E24. At E24, it wants you to change this purple line called Hanzomon line. So this is purple line. Okay, we'll follow the line. And then what do you want us to do? You want to get off at Z02 and change to the orange color, the Ginza line. So we travel on this purple line, follow with my mouth. At Z02, we're going to switch to this Ginza line. And where do we go? This got completely lost. Take the Ginza line towards Shibuya and get off at Hilo. Well, this is orange line here. Hilo is right here. So no matter how you travel on the Ginza line, this orange one, you cannot get to this gray H03 station, which is our destination. So sorry, Copilot didn't get it right. So what do I think? I think the ChatGPT we're using the 4.0 and this Copilot is probably using GPT-4 with a vision model. Let's try this with our open source model. First one up is InternVL. Explain this image to us. I'll expect that is an easy one. Follow-up question. How do I get from stop E17 to H03? Okay, so Tokyo system, that's cool. Follow-up question, here we come. And get it right. Okay, so VL couldn't get it right as well. Remember our starting point is at E17. On this line, it says to start, you want to take the Asakusa line. Well, Asakusa line is a completely different line on top of this Oedo line. So I can't get from E17 to take this line. So that's completely wrong. Next is this fine-tuned Llama 3 model. Let's ask question. First one, they will get it right. It's clearly written, Tokyo subway route map. Now let's ask the follow-up question. How do I get from E17 to H03? Right, so this one got it confidently wrong as well. From the E17, take this Tonza line. Okay, wait a time. Tonza line is this blue color. I'm at this magenta. I cannot take this blue color Tonza line on the top. Okay, so when you look further, it's wrong. Our last model is a Salesforce. I've uploaded the same map here. And I don't expect this model will get it right, but I think it's just funny to ask. And I'll change the question a little bit. Explain this image to me in more than 100 words. Let's see what it says. Our speechless model. Change this to 04. Let's see our speech minimalism model. Sorry about that. PNG. Here we go. Explain this image to me in more than 100 words. And that is not 100 words, that's 1 word. Maximum new token. We recommend setting max new token to control the max length of the word. Okay, maybe we adjust that so it can spit out more than 1 word, other than yes. Based on the warning, we've modified the script to add this maximum new token, and I set it to 150. Well, as you can see, it doesn't really work. So you all know what the answer will be for our real question. How do I get from station E17 to H03? And the answer is turn right. Very funny. Round 5, we want to see how the model performs when it recognizes a foreign language. So as you can see, the image we're uploading is a picture of Chinatown with a 恭喜發財 on the top of it means wish you a prosperity, rich. Let's see whether the model can recognize that. So we asked ChatGPT 4.0 first. What language is that sign in the image and what does it say? Okay, it says the image in Chinese. The text reads 恭喜發財, which is a common Chinese New Year greeting that means wish you prosperity and wealth. Okay, that passes. 1 point for ChatGPT. Here comes the Gemini with the same question. See whether Gemini can recognize it. I can't access the image you sent directly, but based on the location you described, well, I didn't describe any location. The text is likely in Chinese. Here's some additional information about Chinese writing system. Okay, so I'm a bit surprised, but that's a fail. Let's try with the Claude 3 Sonnet model. What language is the sign in the image? The sign in the image written in Chinese character, it says, okay, it's 4 letters. It said this, I can't even pronounce it as definitely not in Chinese, so that's wrong, and also in 3 instead of 4, which appears to be the name of Chinatown or Chinese district. Again, wrong, so sorry. Here comes the Copilot. I'm sure Copilot can get this right. It's pretty basic, to be honest. Analyzing the image, and let's see what the answer is for Copilot from Microsoft. The sign image in Chinese. The text on the sign says is Chinatown. Well, it's not only wrong, it's like the previous Claude 3 model. It's clearly 4 characters and it just translates to 3 characters. Very disappointed with Copilot, but that also means it's probably running different model, right? As we said before, this could be on GPT-4 Vision and ChatGPT, we are trying with GPT 4.0. Okay, let's try the open source models. I'm actually feeling good about this model because these are in China, so they must be good at this character recognizing. So with InternVL, it says 恭喜發財, which translates to congratulations on prosperity, happy new year, blah blah blah. Okay, it's on point to the InternVL. Here comes the mini CPM fine-tuned Llama 3, another Chinese LLM. That's the same question. No problem on this one. So it looks like, I'm not surprised these Chinese models get Chinese right, so not surprised on that one. Lastly, our minimalist model. Okay, let's ask the question. What language is in the sign? Chinese. What does it say? It doesn't tell you. Change this a little bit. I can't say it got it wrong on the Chinese, but it doesn't talk much. What does it say on that sign in the image? Chinese. Okay. Can you... Maybe I can... Well, I'm not giving out. Well, I'm not this model. Can you translate that sign in the image to English? Answer is no. Hey, what did I know? Finally, we are at round 6, the last round, which I expect all models to fail. And this is something I personally struggle with, building an app, reading the correct chess positions. Okay, as you can see, this is a standard chessboard. You have the number on the left represent the rows from 1 to 8, and you have A to H in the bottom to represent the column. So it's a row and column. And then chess pieces are clearly, these are standard images, and I expect this is probably in all LLMs training data set. So it doesn't sound very hard, isn't it? All I'm asking them to do is tell me list all the chess pieces on the board and their positions. So let's try that out. First up, ChatGPT 4o. List all chess piece positions in the image provided. Looks like ChatGPT got most white pieces correct, except in the pawn. So I don't have a e2, I don't have, should be e3 and f4. It got e2 and f3. So that's pretty good for white. With the black, we have the bishop in the c8, which is correct, and the other one is at f8, but says h8. So that is like 2 columns wrong. With the pawns, there's quite a few wrong. At a5 correct, a6 not correct, b7 correct, no, a6, yeah, b7 correct, c7 correct, d5 correct. Then you have e6, which is not correct, f5 is correct, g5 is correct, and h6. The white is slightly better than black. Does that mean it actually recognizes white better than black? Which doesn't make sense. They are all in tokens, in embeddings. It's not actual color being fed to the large language model, isn't it? For the Gemini, we asked the same question with the same chessboard image. So the result comes in here. For the white piece, pawn at a2 correct, pawn at b3 not correct, c4 not correct, d3 not correct, e4, okay, looks like all the multiple pawns are wrong. Rook on h1, h1 yes, another rook didn't say, my other rook is on a1, skip that. Knight on a1, a1, that's not knight. Okay, I'm not gonna bother counting for the Gemini model because mostly are wrong. For example, on black, a7, there's nothing on a7. b6, there's completely nothing on these squares. What is going on? Next up is Claude 3 Sonnet. List all the chess pieces positioned on the board. Let's see how it did. Not so good, except there's no bishop on f1 for the white. There's no knight on b1, but it's on the b5, but there's knight on g1, that's correct. With a pawn, a2, b2, c2 incorrect, d2, e2 incorrect, g2 and h2. So g2 is incorrect, h2 is correct. On the black pieces, kings on e8, queens on d8. And then you have rooks on a8 and h8. So the rook is on a8, but the other rook is on h7, not on h8. Knights on the b, no, not on b8. There's one on the g8, yes, but not on b8. Anyway, Copilot will be same sort of thing, I guess. Let's see. Lots of errors with Copilot as well. For example, this d3 is not a white pawn, and a7 is also not a black pawn, so not good. This is the open source InternVL, and let's see. King is on d1, but my queen is not on d8. That is queen of black. And also this pawn, no good. Here is a fine-tuned model of Llama 3 by Mini CPM. Same sort of result with this Mini CPM Llama 3 model. One thing I don't quite understand that if you mistaken different pieces, I get it. But if you mistaken the square that has piece and don't have a piece, I don't quite get it. For example, bishop is on c1, yes. Bishop on f1. f1 is blank. There's nothing, only light color and dark color square, and if it's empty, it's empty. Mistaken with another piece, or you think there is something there. This looks quite different, to be honest, compared to the square with the pieces. Lucky last is our Salesforce Blip. Well, it's almost a joke now if I ask this model to answer me anything, but I just find it funny. Okay, list all chess in the image provided, and the answer is all. What a surprise. And we couldn't get this max new token working as well. Well, it didn't give us any error, but also it didn't really make the answer a bit longer. So if any one of you know how to use this model properly, please leave in the comment. I'm probably using it the wrong way. Here you have it, folks. The battle of multimodal LLMs in terms of the image analysis. I'm sorry this is a quite long video. I hope you only skip to the part that you're interested instead of watching the all 6 rounds. It's very long. As you can see, in terms of image analysis, GPT-4o model, the Omni model, no doubt is the best model and way ahead than other models. Most models, for example, got the parking sign correctly. They can read it, but they are a bit short at the reasoning when I ask questions, especially tricky questions. With the food menu, it's a handwritten on chalkboard photo. GPT-4o was able to read it most things right, including the menu and also the Wi-Fi password, the Instagram handle. Those are hand-drawn images and handwritten text. For our Grand Nikko Hotel in Tokyo Bay, most model obviously can detect in Tokyo it's a hotel, but only 2 models has got the hotel name correctly. The Japanese Tokyo Railway reading, initially I thought that could be a flaw test because being Tokyo, this subway system is so famous around the world. The information is most likely in their dataset for trainings. And that's probably still true, but only GPT-4o was able to get it right, helping us to get from point A to point B. All the other models have used completely either wrong station or wrong line. With the foreign language detections, we've uploaded a picture with some Chinese in it. Only GPT-4o got it right. I'm not surprised the other 2 open source models got it correct because they were developed in China, but the other models has got it wrong completely. And round 6 is the most challenging round, and I really want to get it working, but so far I have tried many things and I couldn't find a model that is able to read the chessboard correctly. So if you guys know how to work around, overcome that problem, please leave a comment and hopefully we can have a workaround around this issue. Now we're gonna wrap up this video for the image analysis for the battle of multimodal LLMs. And the next video we're gonna do in the near future will be the video analysis. Thank you for watching and see you next time. As I was about to upload the video, Claude came up with 3.5 Sonnet. And since everybody on Twitter or the X is pumping this model so hard and claiming this is better or at least as good as GPT-4o, I think it's only fair to include this model in our test. So let's start with the first one. Round 1. Explain this sign to me. So we upload the same image, and remember we tested it with a Claude, the 3.0 in our previous test. So 3.5 Sonnet. The sign provides parking information, no parking symbol. That's good. 2p, 2 hour. Times restriction indicates these parking rules are effective from 8 to 6 p.m. Monday through Friday. Remember the other 3.0 didn't get this right. The red arrow pointing left and the green arrow pointing to the right suggests parking rule applies to different sides. That's much better. In summary, this sign is communicating that there's 2 hour free parking allowed on the weekdays between 8 a.m. and 6 a.m. Even notice it's free parking because there's no meter sign on there. That's really good. Let's ask these tricky questions. 3 hours. Right, 3 hours. Yes, you can park on the right side of pole from one. Okay. 2 hours allowed. The green arrow pointing right suggests these rules. Since 1 to 4 is within, you can park there. However, remember that you're limited to 2 hours of parking. If you need to park a full 3 hours, you will need to exceed 2 hour limit, potentially receive parking ticket. So actually this is much better. Explains really clearly. Round 2 is our breakfast menu. Is there anything had eggs on the menu? After carefully review the menu display on the image, I don't see any items that explicitly mention eggs as an ingredient. Okay, that's good, and that's what we expected. The other Claude got it right as well. Next one, the Claude 3.0 Sonnet didn't get it right. What is the Wi-Fi password? According to the image, there is a free Wi-Fi available, and the Wi-Fi information shown at the bottom of the right menu. Free Wi-Fi, okay, the password appears to be Garrison. That's good. It mistaken the one with I, but I think this is much better than 3.0. Let's give it a pass too. Round 3. What hotel is this? The Claude 3 Sonnet couldn't tell the name of the hotel. It didn't mention it's Grand Nicole. Does this one say that? Doesn't specify identify hotel by name. However, based on distinctive architecture and location, this appears to be Grand Nicole, Tokyo. That is exactly the hotel name we're looking for. 3.5 got it right. Another point. Round 4 with the Claude 3.5 Sonnet. Remember, this is a hard one. Only GPT-4o got it right. The image shows the Tokyo subway route map. That's fine, everyone got that one right. Next is the question. How do I get from stop Kachidoki E17 to Hiro HO3 using subway? I think it got it right as well. Just let's read this summary. Starting from E17, you take this Oedo line and you're gonna write 5 stops to Lobongi at E23, transfer to Hibiya line and get off the HO3. You got everything correct. Amazing. The only thing is, here it says take Oedo line towards that direction counterclockwise on the circular line. You travel from E17 this way, isn't that clockwise instead of counterclockwise? But anyway, we're gonna give 1 point to this. This is quite good. So far, the Claude 3.5 Sonnet is ticking every box. I'm very impressed. Now, round 5, what language is it on this side? What does it say? Let's test its foreign language recognition. The language on the sign is Chinese, and it says 恭喜发财, which is correct, but in a simplified Chinese, that's okay. Congratulations and be prosperous. You got it right too. We are finally at round 6. So far, everything that GPT-4o got it right, 3.5 Sonnet got it right. I'm very impressed by this small model. Now the last image, the chessboard positions, nobody got it right. Let's see how our Sonnet performs. Okay, here is the list. Whoa, that's a lot. Let's observe them. Okay, I think the chessboard has been remaining a challenge for all models, including 3.5 Sonnet. This is not the way I wanted to list it, but we can read it. It thinks every 8 row has something. Clearly, there's nothing on B8 and there's nothing on H8. So I won't go through the rest. I'm pretty sure there will be quite a few mistakes. But that means our Claude 3.5 Sonnet, which is a much smaller model than GPT-4o, has performed as good as GPT-4o in terms of image analysis. So these influences on X is correct. This is a really impressive model and fast, very fast. I'm looking forward to the Opus, the larger model, to get released very soon, and Haku on 3.5.